Hello guys, a quick video today about Mercury Rectifier tubes. These are industrial Mercury Rectifier tubes. This one was meant for cinemas, so this rectified the voltage coming out of a big transformer to use in carbon arc lamps that were used for cinema projectors. And I actually have 3 more of these, so 4 in total. These are the connecting wires. One of them is damaged. This one, its filament is like partly melted together, so it draws way more current. And because this apparently was running a short circuit once, and it melted part of the filament because there was just too much current through it. But it still works, but you need to use a lower voltage, so it achieves the same filament wattage. Obviously, it won't perform to datasheet, but it works. But it needs external cooling because it draws way more current in these connections. Obviously not rated for that current. The other two ones work perfectly. And I actually have one wired up here today. So yeah. So it uses a normal filament, normal tungsten filament, just a coiled coil, but it's inside of the cylinder. In this cylinder, actually one of them is focusing the arc, and there's an auxiliary electrode. Two auxiliary electrodes, and they're just wired together. And this is to lower the voltage drop of the mercury. So it basically pre-ionizes the mercury, so it has an easier time igniting to the two anodes. The anodes actually are made of carbon, and these have this weird shielding around them. I'm not sure what exactly the point of this is. Probably heat dissipation, cooling, something about the mercury, gas pressure, all that. Obviously, the tube is quite large, so the mercury can condense, and so the pressure stays near constant. These tubes require 2 minutes to warm up, and they actually need 29 amps of heater current. It's around 55 watts of heating, and the voltage is around 1.9 volts. So yeah, Philips 1829 tubes, 4 of these. So I actually have it wired up. This is a center tapped 35 volt transformer. So it has 35 volt center tap and then a 35 volt section. This can deliver 10 amps. This is a car automotive lamp as the load. So yeah, the two outer wires go to the two anodes. The other wire is where the DC comes out of, and the tube, obviously. So yeah, the positive comes out of this end. This is the negative wire. Right. So I have a multimeter measuring the output. It's set to DC, as you can see. So you can see we're actually getting DC out of it. So let me put the variac, and you can see for a lot of the variac, it just does nothing, right? Because it has way higher voltage drop, so it's not going to pass any current. So now, one section is ignited, the other one hasn't yet. This section is a little bit less voltage drop, but we're actually seeing some DC out of it. But if I raise it higher, now both sections are working perfectly. You can see the lamp is starting to glow. We're getting 1.4 volt DC out of it. But yeah, this has a voltage drop around 20 volts. So, efficient rectifier. And it's designed to handle 25 amp. So, multiply 20 times 25, yeah, dissipates a lot. Basically 500 watt dissipation. But it can handle it. So yeah, this is at 50% of the variac, and getting 8 volts out of it. So now we have what the lamp is rated for, around 12.6. That's fine for it. See, the lamp is still it's still flashing, of course. We still see the mercury because a lot of the main sine wave is still being chopped. You can see each anode is alternatively switching. Beautiful tubes. And this power supply is the auxiliary power supply to lower the voltage drop of it. So Philips actually used a smaller germanium or selenium rectifier to basically bias this tube so it could rectify a lot more current. These are from the 1950s. Yeah, wonderful little tube. These are the other ones. All Philips 1849 tubes. This is the connecting wire that connected the anode. They have thumb screws on the top. Yeah, and these can rectify their peak inverse voltage is 360 volts, so they can do mains voltage at best. So yeah, sadly not high voltage, ultra high voltage rectifiers that can use like for Tesla coils or something, but theoretically you could use this in solid state stuff if you want to be incredibly strange. Yeah, so if the auxiliary electrode enabled, you can still see the mercury glow because it's biasing it. This is with it disabled. You can just see the filament glow. The data sheet is available online for these. There's also a small brochure, small book basically about how to use these. They have circuit configurations and other stuff. Hold on, let me find it. So yeah, it's this one. That's what it's called. Industrial rectifying tubes. Also has a datasheet for this. This is from 1957. Yeah, it goes a lot about the theory, calculations, circuit descriptions. Amazing stuff, really. Big rectifiers. So yeah, also has pictures and data sheets of the rectifying tubes. Interesting rectifiers. It also has mine in there. Let me find it. Wait, that's way too much at the bottom. Rectifying tube. Yeah, also has like single mercury rectifiers. You can see mine just has 2 of these. So is that it? No. That is the one that I have. 4 of these. You can see 1.9 volt, 29 amp. Heating up time 2 minutes. Yeah, recommended minimum heating time. This may be decreased to 60 seconds, so if it's urgent, but it's, I guess, recommended. Like worst case scenario, I guess when it's cold outside too. Let me shut the heat off now. But yeah, they mention natural air cooling. Obviously you should have this such a way that it gets cooling from the bottom, like it's mounted towards like the side, the unit, so it receives cooling from the top to the bottom. From the top to the bottom, no, from the bottom to the top, so just natural air cooling. Obviously, this is not done how I wired it, but it should be done like that. For a short time, it's fine. It also mentions that the mercury temperature should be around 30 to 80 degrees. Because otherwise, it's not... It's the characteristics are gonna vary. It might even arc over between the anodes and other stuff. Obviously, in operation, it would be good to have a fuse for each anode, so in case it arcs across. Yeah. The evacuation system is over here. The auxiliary electrode connects to the bottom there. So yeah. Interesting tube.